Hey, I was going to get to the intermediate value theorem last video, but it ran a little too long, so I'm going to break it up into two videos. The intermediate value theorem, or the IVT as it's abbreviated, is an application of continuity, and it seems fairly obvious, but you need to know the formal definition of it and how to apply it if they ask you in an AP test. So intermediate value theorem, or IVT for short, because intermediate value theorem is very long and fancy and nobody needs to really say that. It's kind of pointless. So before formally writing it, because it's pretty lengthy, I want to explain it using a graph. So here we go, let's make a very long graph. And let's just draw our favorite function. I'm going to draw it in red, Whoops, I'm still using a line tool. Whoopsie. Not red, I guess, blue. Wow. I picked red and it selected blue for me. Nice. So let's say this is our function. And this is x, this is y. I'm gonna erase this little smidgen because it's annoying me. OCD. And okay, so let's pick an interval. So I declare this to be a, and I declare this to be b. And if we draw dots, little dotted lines, we hit this red point, and if we draw dotted lines, boop, 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 we can find f of a as well, and we can draw lines that connect to the y-axis. Hold on, let me just elongate this axis to accommodate for that. So what is that? So this value is f of a. This value is f of b, right? So this is our graph. A and b are x coordinates. F of a and f of b are y coordinates that correspond to the x coordinates a and b. And I claim that, and this is very important, and this is why we talked about continuity in the last video, we have to assume f is continuous. And this is really important, because if f isn't continuous, this whole theorem just falls apart. It just doesn't work anymore. It has to be continuous over the interval. Oh, I should specify that. Over the interval AB. That's very important. So I claim that between f of a and f of b, there is a point here, and I'll call this f of c. And I claim that this y coordinate f of c, if it is between f of a and f of b, there is a corresponding, at least one, corresponding x coordinate c such that f of c is between f of a and f of b. So you may be thinking, what the hell did he just say? Well, let's try and make this a bit clearer and draw a horizontal line, y equals f of c. So this is y equals f of c, this line, and you can see that this line intersects our function at some points, namely this point. It just barely touches this point, and it's actually probably a tangent, and this point. Well, there are 2 points, so I'm going to label them C1 and C2, even though usually there's just 1 point, but there's no harm if there's more than 1 point. And the intermediate value theorem states that C1 and C2 are always going to be between A and B. If f of C can be picked between f of A and f of B, the corresponding x-coordinates C1 and C2 can be picked between A and B. And that is basically visually what the intermediate value theorem is saying. That if a function is continuous, it has to, the function, if it connects A to B, it has to include within that interval all values. All values, so I'm going to write that in light blue. It has to include all these values in between f of A and f of B. That's just what the intermediate value says. So this light blue line might explain it a bit better. All these points on this light blue line, because it's also continuous, it makes sense, right? And with this light blue line, you can see it even better. Like f of C, yeah, like, if there's an f of C, there's going to be this C value that is between A and B, because obviously this graph includes all those points. So that's basically what the IVT is saying. I'm probably over-explaining it, so I'll just give you the formal definition now. Although I think this graphical visual way is like a lot better to help you get it, I guess. So if oh crap, line tool. I forget how it's exactly worded, but for an interval AB, for an interval AB, if there is a K between f of A and f of B, there is a corresponding C between A and B such that f of C is equal to K. I think that is a fair way of expressing it formally. And that is what we call the intermediate value theorem. How do we apply it? Well, maybe next video.